All right, good morning or afternoon. Just wanted to start by telling you we are starting chapter 2. And so whenever you see an assignment, it will say 2. That means chapter 2, lesson 1.1. So today we're going to do a little bit of an activity lesson, and then you'll do your review and preview. So the homework that you did on Monday was the closure problems. And just so you know, all of the closure problems have answers to them on the page after the closure. So just make sure if there's one you didn't know how to do, look at that and make sure you ask questions as we go. In 2.1.1, students are going to be introduced to a problem about mirror reflections. So just thinking about the things you know about reflections that will motivate much of the work in section 2.1. Students will learn how to name angles and will learn 3 main relationships for angle measures: supplementary, complementary, and having the same measure. Students will also discover that vertical angles have the same measure. So we've got a lot of vocabulary here. Make sure you take notes as you need to. Supplementary angles, complementary angles, and vertical angles. So as we look at the diagram of equilateral triangle ABC, the top of the triangle is referred to as angle A, or written as angle A. Point A is called the vertex. The measure of angle A is the number of degrees in that angle. Written the measure of angle A. Since triangle ABC is an equilateral triangle, write an equation showing the relationship between its angles. So we know that the measure of angle A would equal the measure of angle B would equal the measure of angle C. Aubrey rotated ABC about point A and found A, B prime, C prime. She told her teammate Maria, "I think 2 angle A's are equal." Maria did not know which angles she was referring to. How many angle A's can you find, and are there more than 3? And so we had this angle A, we had this angle A, and we had this angle A. And then we had this angle A. So there are several ways you could name angle A. Maria asked Aubrey to be more specific. She explained that one of my angles is angle B, A, B prime. So she was talking about B up to A, back down to B prime, meaning that angle. At the same time, she marked her 2 angles with the same markings to indicate that they have the same measure. So then she was talking about C prime, A, C, and that's how she showed that those 2 have the same measure. Name the other angle and be sure to use the 3 letters. And so we always name an angle from the outside, B prime, all the way up to the angle that we're talking about, A, coming back out to what we want, C, and so this would be angle B prime, AC. When you know 2 angles have a certain relationship, learning something about one of them tells you something about the other. Certain angle relationships come up often in geometry and are given special names. 2 angles whose measure equals 90 degrees are called complementary angles. Study it, learn it, memorize it, know it. Complementary has a sum of 90 degrees. Since angle ABD is a right angle at the diagram, ABC and CBD are called complementary. If CBD is 76 degrees, what is the measure of angle ABC? So we're looking for that one if that's 76. Well, I know that they add up to 90. If I take away the 76, I get 14. So this would be 14 degrees. Another special angle is when they form 180 degrees, like we have going on here. If they're 180 degrees, they're called supplementary angles. In the diagram at the right, LMN is a straight angle, which means it's 180 degrees. If LMP is 62 degrees, what is PMN? And so we would again take 180 degrees, take away the 62 degrees, and get 118 degrees. Now consider the diagram below, which shows line AB and line CD intersecting at the point E. If X is 23 degrees, find the measure of angle AEC. So I'm looking for this angle measure. Well, I know that this part right here is 180 degrees. So if I take 180 degrees, take away the 23 degrees I already have, I get 157 degrees. So that's AEC. The measure of DEB is over here. So again, if I take a look at this angle measure right here, from here all the way over to here is 180. So I have basically the same measurement. 180 minus 23 degrees is also 157. So if this is 157, then I then know that angle CEB is also 23 degrees. Based on your work in part C, which angle measures have the same as AED? And so I look at AED, the same one is angle CEB. Remember, your vertex or your center point is always in the middle. When two lines intersect, the angles that lie on opposite sides of the intersection are called vertical angles. For example, in the diagram that we just showed, AED and CEB were vertical angles. Find another pair of vertical angles in the diagram. And we already know it was this and this. Travis noticed that vertical angles in parts C and D of the problem 2-3 have equal measures, and wonder if other pairs of vertical angles also have equal measure. Return to the diagram above and find the measure of CEB. If X was 54, so I just rewrote it here. If we look at the diagram above, but this time I give this 54 degrees, based on your observation, write a conjecture, a statement based on an educated guess that is unproven, and start with vertical angles. And I might say vertical angles are the same measure. In problems below, you will use geometric relationship to find angle measures. Start by finding a special relationship between some of the sides and or angles and use the relationship to write an equation. So we're looking for the measure of angle MNP. Well, I know that JNP is 180 degrees, and I know that angle JNM is equal to 152 degrees. So therefore I know that angle MNP is equal to 28 degrees because these are supplementary. here it's showing me that this is the same as this. And if that's the truth, then I can then say that 4x minus 5 is equal to 3x plus 2. And I know enough about algebra to solve and get x is equal to add 5 to there and add 5 to there. So x is equal to 7. So 28, 7 times 4, minus 5 would be 23 degrees, and 3 times 5 is, or 3 times 7 is 21, plus 2 is 23 degrees. Using what we know here, these two add up to 90, so I could say 2x minus 4 plus x plus 7 is equal to 90 degrees. So I have 3x plus 3 equals 90 degrees. Subtracting 3 from both sides, I get 3x is equal to 87. Dividing both sides by 3, (29 degrees). So x is 29. 58 minus 4 would be 54 degrees up here, and 29 plus 7 would be 36 degrees, and 54 plus 36 equals 90 degrees. Here, I know LPQ is this big angle, and LPN is right here. And it says, what do I know? Well, I know that if this is x, then this also has to be x because they're vertical angles. So I know x plus 28 plus x is equal to 180 degrees. So 2x plus 28 equals 180 degrees. Subtracting 28 from both sides, I get 2x is equal to 152. Dividing by 2, I get x is equal to 76. So this would be 76, and this would be 104. Learning log, again, is another name for notes. Make sure you take time to kind of debrief what you learned in this lesson. So you might want to write in here what vertical angles are, and what their relationship is, that they're equal, what supplementary angles are, and what their relationship is, that they equal 180 degrees, complementary, and what their relationship is, that they equal 90 degrees. And again, there's some notes here, complementary, supplementary, and make sure you also know what vertical angles are. Your review and preview for today is 28 through 13.